Again from Unigroup Engineering Dyno Room. Today we have a S15 Silvia SR20 in for a dyno checkup. S15 Silvia's, we've been working on this for a long time. One of our favorite cars back from 2002 when we first opened. Since then we've seen many Silvias and we still like them. We're still just as passionate about the Silvias. He's here today for a dyno checkup. It is important to get one of these done, especially on a modified car. We think at least once a year. It allows us to pinpoint problems, if any. Even if there are any problems, it's a peace of mind thing for the owner that the car's been on the dyno, we've checked all the vitals and the car's good to go. Brian has nice number plates on his car. I'm quite a fan. So he's running a fairly standard SR20 DET with the bolt-ons. So I can see that he's still got the standard injectors and standard airflow meter, but he has upgraded the piping to metal intake pipe. Metal intake pipes are a good idea on cars this age. The original rubber ones, they can tend to suck themselves shut under high power. When I say high power, even as early as 180 kilowatts, I've seen them suck themselves shut, so it's a good upgrade, that one, to any S15. He's got full exhaust system. He's got a front mounted intercooler, so he's pretty much got the basic bolt-on mods. Also the mandatory boost controller, of course, so we can dial in some additional boost and make some additional power. He's got the Go Fast Bits G-Force boost controller. I don't mind these units, they are quite popular in Australia. They do a reasonable job and they give you 6 boost presets, which is more than enough for most guys. Here is the car, just an overall look. Here is a look at the first power run that we've just done before we started filming. On this car we've started at the lowest boost level we've got available at 10 psi. At 10 psi we are doing 160 kilowatts to the back wheels. So I've got the dyno set up to display 0 to 200 kilowatts, and we've got engine RPM across the bottom axis from 2,500 all the way to 7,500, and also got air fuel ratio displaying at the moment. We can see the mixtures here. It is running under full load, about 12 to 1 air fuel ratio, which is reasonable for a car like this. Here is a look at the same run again, but this time with boost pressure in PSI on the right hand side axis. So we've got 10 PSI line there. You can see the car starts at about 7.5, 8 PSI beginning of the run at 3,000 RPM. We hold the engine at full throttle there to develop the boost that it can, and then we start the run, and by the end of the run we've got about 11 psi. I just got asked a question by Brian about this noise when we cycle the ignition. Just for sake of sharing information with everybody out there, I'll let you guys hear it. Okay, no, it didn't quite happen this time. Take 2, maybe power off completely. Oh, here we go. That buzz, sorry, I was speaking over it. It is the boost controller solenoid that's pulsing. It happens on power on and power back on, power off and power back on when we cycle ignition. Yep, there it goes again. So that's nothing to get worried about. It's a characteristic of these G-Force boost controllers. When we dyno the cars, we usually like to have 2 people in the dyno room, one operating the dyno in the car as you need to, and a second spotter standing back and just overlooking the car. In case if anything goes wrong or we see something strange, we can wave to the operator and shut it down. Some of the more experienced viewers may have noticed that there was a cut at the end of that power run where the engine basically came to a halt. Now that is the 180 km/h speed cut that's on the Japanese versions of these cars. These cars were originally speed limited to 180 km/h. Coming back to the power graph, we've elected not to put any more boost into this engine because of this lean spot here. As we turn the boost up, that point stays roughly where it is at about 13.5, 14 to 1 air fuel ratio, which is not great. Now Brian's asked an interesting question as we were working on his car. His question was, based on that power run, can we tell if there's existing engine damage? Well, here's the answer. Look, doing a power run, one good indicator of a healthy engine is that it makes the expected power. So the dyno run for checking things like that probably is effective from the sense that you at least get to see the power output of the engine. So if one of the cylinders was down on compression, if there was excessive wear and tear, or there was something unusual, well, one of the ways that the car can present itself is by lower than expected power output. In this case, we're not seeing that. So as we're checking this car out the way it is, it seems to be working okay. Brian's been asking interesting and valuable questions, and I thought I'll keep the answers in the video for sake of sharing information, because it is actually good questions he's asking. He's asked me that he's compression tested this engine and he's got fairly low results, about 100 across the board for all of the cylinders. Could something be wrong? Okay, here is my answer. Depending on the test procedure and the gauge used, you could get a different reading. Normally on this we expect around 150 psi, 155, that is what we see. Now he's gotten 100 across all cylinders. When there is a problem with an engine, usually you get one of the cylinders quite a bit less than the others. We normally aim for about 10 psi within the cylinders. So if you've gotten all 4 of them at 100, there could be a few things, and one possibility is that the test process that you've employed or the gauge you've used, it seems to be reading lower than expected. When you get a low reading across it could be other things, such as you've got the cam timing out. But in this case, if the cam timing was out on this car, we would also be we would reflect that on the power output that we've just measured. We've nearly come to the end of this video, so a few final words on Brian's S15. It was a good idea running the car up to check for things like fuel mixtures, boost, power. It gave us a good idea of where the car is at. So everything checked out fine, and car seems to be performing as it should. Thanks for watching. If you like this type of presentation, this type of information and these types of cars, like and subscribe. We've got plenty more videos coming.